What if gravity isn't really about bending space itself, but about how tension in the fabric of space sets the rules? In general relativity, gravity is often seen as mass and energy curving spacetime, which in turn dictates the motion of objects. This elegant theory explains planetary orbits, gravitational lensing, and redshift very well. But here's the catch: it gives us a nice picture without explaining what's really going on at the deeper level. Why is spacetime bendable? Is it some sort of medium? Or is it just an abstract geometric surface? In energy filament theory, we take a completely different starting point. Instead of assuming spacetime is smooth and just curving, we start with a fabric of tension A, tension C that can be stretched, wrinkled, and textured. The so-called spacetime geometry we see is merely the average appearance of this C at large scales. Gravity, in this picture, is simply the large-scale slope of this tension field. It's a transition from areas of tightness to areas of looseness. Objects fall because, as they slide along this slope, it minimizes the overall cost of deformation for the object and the whole C. At large, smooth scales, you can abstract this tension field into what seems like smooth geometry. And yes, you can reproduce the classic matter curves geometry, and geometry tells matter how to move. But in energy filament theory, the bending is not of abstract geometry but of the tension configuration itself. Spacetime, rather than being smooth, is rough, with textures and steps at extreme scales, such as near black holes, where tiny steps in tension become visible. This is where things like black hole instantaneous pores come into play, which we'll explore in the next episode. When we look at gravity after unifying all the forces, we see that it's not some isolated geometric oddity, but rather a macro mode on the same tension C as the other forces. The strong force fills gaps, the weak force rearranges unstable structures. Electromagnetism controls texture and flow, and gravity forms the large-scale slope that determines the overall layout of everything. It appears the weakest because it doesn't dominate local interactions. It doesn't focus on just a few threads, but its effect is the largest because no matter how you manipulate local tensions, everything must align to this larger slope. Tap follow, share it on New Physics, Clear Universe.